Okay, the objective of this video is to learn about factoring polynomials by grouping. And factoring polynomials is grouping usually when you have a four-term polynomial. Step one, well, technically step one is always going to be factoring out a GCF. But assuming you've factored out the GCF and you're looking for just factoring the polynomial by grouping, then your first step there would be to break the four-term polynomial into a sum of two binomials. So if you had something like 4x to the fourth plus 3x cubed plus 2x plus 5, you would break this into two separate binomials that you would have the sum of. And then you would factor out the GCF, the greatest common factor, from each binomial. And then from there, if the two binomials are the same, because once you've factored out the GCF, let's say, let's not continue with that same example, but let's say we factor out the GCF, we end up with something like 2x, x plus 4 plus 3x plus 4. Let me undo that a little bit here. X plus 4. With something like that, you'll notice that the two binomials here are the same. That's going to become one factor. The other factor is going to be the 2x plus 3. So we factor out the one binomial, because it's like a term inside this one term. This is one factor. Inside this term, it's a factor. Since it's a common factor in both terms, we can now factor out this term, this one factor from each of these terms. To do that, we would have to factor out the x plus 4. Taking it out of this one and out of this one will leave us with 2x plus 3. And we could always double check our answer, even though it's not an official step. We can double check our answer by doing the FOIL, or the distributive property here. First, outer, inner, and last, which should bring us back to the original polynomial. We don't have that here, so we can't do that here. We're going to go through a couple examples on the next screen. Okay, here's our first example. As I said, step one, we're going to break, well, step one should be to factor out a GCF, but there is no GCF inside of any of these four terms. That's the unofficial step one. It's kind of step zero. Our official step one is to break into two binomials. So we're going to have the one binomial is the 2x cubed plus 8x squared. And the other one's, and it's going to be a sum of these two here. It's kind of going like this. 3x plus 12. Doesn't matter what sign we have here. We're going to carry that sign to this term. We're just going to make it a sum each time here. Okay, now what we do is we factor out any common factor in this binomial and any common factor in this binomial. Looking at this one, I can see the 2 and the 8 have a common factor of 2, and the x cubed and the x squared have a common factor of x squared. What's left inside there is just going to be an x plus 4. When you divide the 2x cubed by the GCF of 2x squared, you're left with just x. When you divide 8x squared by 2x squared, the GCF, you're left with just the 4. Okay, now I find the GCF over here. The GCF of the numbers is a 3. And again, this is going to be addition. GCF is a 3. And we see that is the only GCF. There is no GCF in the variable. So you end up again with an x plus 4 over here because 3x divided by 3 is x. 12 divided by 3 is 4. Now we're going to factor out that common binomial, which is going to give us the x plus 4 in the beginning here. And then we're going to take this term and this term to make this binomial, which is going to give us 2x squared plus 3. Okay, now before we continue to this next one, looking at my notes, I realize I should not have that y there, so I'm going to cross off that y, get rid of that. And this should be a negative 16x squared. 16x. So working with that, those changes I made there, I'm going to break these into two pieces. And when I do this, I'm going to make this a sum of two binomials. All right, now, again, this change I made here is simply because it's not what I was supposed to be given. I made a mistake when I typed this up. This should have been a minus. This should have been no y there. This is what this should have been to begin with. Breaking it into the two pieces. Looking at the common factors of that first binomial there, I see a common factor of 3 in the numbers and a common factor of x squared in the variables, which leaves me with a 2x plus 3. When I divide 6x cubed by the 3x squared, 6 divided by 3 gives me the 2. X cubed divided by x squared is going to give me the x. 9x squared divided by the GCF of 3x squared. 9 divided by 3 is 3. X squared divided by x squared is 1, which just keeps it as a 3. Then we still have that, as I said, plus sign there. And we're going to factor out the common factor between these two terms here. Well, now I see I can find a common factor since these are both negatives. I'm going to factor out a common factor of negative 8. There is no common factor with the variable, so I'm going to end up with the GCF of negative 8. And I'm going to have 2x plus 3, because negative 16x divided by my GCF of negative 8 is going to give me a positive 2x. Negative 24 divided by negative 8 is going to give me a positive 3. Now, yes, I said keep this as a plus, so we're actually going to be adding the negative, but adding the negative is the same as subtracting the positive. All right, now, I have a 2x plus 3 and a 2x plus 3. They are both common binomials, so I can pull that out as a common factor of those terms. So I pull out the 2x plus 3 as a common factor. What I'm left with, after pulling that out there, I'm going to left with 3x squared minus 8. Again, I know we said plus, but plus the negative is the same as subtracting the positive. And that would be our final answer on that one. Of course, we should always box or circle our final answers. So to do so here, I go like that. Okay, looking at this next example, again, the first thing you really should ask is if there is a common factor between all four terms. And no, there isn't in this case. Then we're going to break it up into our two binomials. Looking at this first binomial, I see a common factor of negative 7. So I'll put a negative 7 with the parentheses here. Inside the parentheses, there is no common factor with the variable because this one has one, this one doesn't. Dividing negative 35 by 7, negative 7, I get 5x. Dividing negative 14 by 7, I get a positive 2. Plus, the common factor between these two numbers, the coefficients, would be a 3. And the common factor with the variables, since they're both x, the common factor would have the least exponent. So this is going to end up being 3x squared for the common factor, the GCF. Dividing that out of the 15x squared, we get 5x. Dividing that out of the 6x squared, we get a plus 2. So again, we end up having the common binomial here and the common binomial here. And since this is one term and this is one term, this is one factor within the term, they are like factors, they're a common factor. We can now pull out that 5x plus 2 as the common factor of the two terms there, and we end up with a negative 7 plus 3x squared as the second binomial factor. Now, could I write this as 5x plus 2, 3x squared minus 7? Yes. Could I write this term first and this term second? Yes, I could switch these two factors around. That would not be a problem. Multiplication is commutative, so I can change the order. I can write this as 3x squared minus 7, 5x plus 2. It's still the same answer. This is the same thing. And this is the same thing as that. So no matter which one of those I choose, it's the same answer. But only because they all going to bring me back to this if I do the FOIL. Maybe not necessarily in, the terms may not necessarily be in that order, but they will bring me back to that same beginning polynomial. Okay, let's look at this next example here. In this case, we're going to break this up into the two binomials like this. There is a common factor of 5x cubed between these two terms here. This is divisible by 5, this is divisible by 5. X cubed is the smaller of the two exponents there, and they both have x. All right. Then we're going to be left with just x plus 9, and no x there because it took the cube out. Over here, we're going to have a common factor of a positive 2, and no variable, so it's just plain positive 2 for that. We're going to be left with x plus 9 over here. Again, we end up with these common binomials here as factors. So we can factor those out. So we end up getting an x plus 9 times the 5x cubed plus 2. And that would be our final answer on this one. This one I gave a screen of its own because this one is going to have a GCF through the whole thing. If you look at this, all of these terms are even numbers. So we can factor out a 2. So before we get through the factoring by grouping, we're going to factor out a 2 to make this 12x cubed minus 3x squared plus 4x minus 1. Then we break this part into the two binomials. There is a common factor of 3x squared in this first set. So let's change this to a bracket like that. We take out a 3x squared, and that's going to leave us with 4x minus 1. And over here, we already have 4x minus 1. But we have to have something in front here. So we're going to do a plus 1. We're going to factor out a 1 from there. Normally, you don't factor out a 1, but you do need to have this coefficient here in order to work with that factoring out the common factor of 4x minus 1. So when you do this, you're going to end up with 2, open parentheses, 4x minus 1, the common binomial, and 3x squared plus 1. And this would be your final answer. Now, you could put the 2 in parentheses as well if you really wanted to. That would be fine. But it's not required. We could leave it like it was. Well, I hope this video helped in learning how to, at least practicing how to factor by grouping with polynomials with 4 terms. Please feel free to subscribe to my channel. I do not monetize my channel. I do not get any money from this. I do this because I want to provide help for my students and others. I do not monetize it because I do not want to have commercials in the way of getting to my lessons here. So please enjoy, subscribe if you would like to see more, and find out when I put up new videos. Thank you.